Well, in fact, we have these, and we may have some calculation. Later, we try to feel some way to have the calculation. But before that one, we have a scenario in daily life. We use Caravan. Caravan, right now, you can see the cars here. So I think you can guess what is the meaning of a caravan. Here, this one. Well, in fact, in the past, I may click on the hyperlink and so they can know all the details. But this semester for the course, I don't know the meaning in English directly. And also, I don't have the Chinese. So I think if you understand this one, it doesn't mean I need to click on the hyperlink here. So let me skip it. So here we have a caravan analogy, and we want to know something. And once knowing something, you can reconsider the calculation here for the current example. The same as the situation in the 4 types of delay for the packets. Well, later we can have some mapping. At least let us consider caravan directly. Well, here we have a 10-car caravan. All right, 10 car. And without know this, propagate. So propagate here, in fact, the same as the propagation of a packet. So this phenomenon, the same as the packet to have the propagation. Cars propagate at the speed here, and we also have a toll booth. Toll booths actually need to collect the fees. If you check high speed, actually you cannot see the toll booth right now because we have ETC. However, we have the old scenario. We have a toll booth. Well, the toll booth tax you to go through using the current value of a time period, 12 seconds. All right, so here we have 12 seconds to serve the car. So of course we need to have the time. If we have the current time, 12 seconds. 12 seconds, what kind of delay you can, what type of delay you can map it? Here we map it to the transmission delay. Well, normally don't think it's the transmission delay. It should be the processing delay. But at this moment, we map it to the transmission delay. What that means, something like right now you have a link before the toll booth, and you need to allow the toll booth to go to the next link. So because of this, we map it to the transmission time, transmission delay. All right, so at this moment, we have a propagation delay, we have the transmission delay. If we have this, right now we want to tag this example to have the analogy. What kind of analogy? Here we have a car, and the car maps to beat, and the caravan actually is a packet. Well, why we want to talk about this example? Because of this. However, sometimes they are not the same. So even we have the mapping, sometimes you can ignore the current example, but consider the real example directly. Well, at this moment, you are asked to consider example. So we continue the question posed here. How long until caravan is lined up before the second toll booth? If we have the given information, and then it says we want to ask how long, and so that we can see the caravan line up before the second toll booth. Well, I think you can have your own way to know the calculation, but I just follow the current way to let you know the steps to have for the calculation. The first step here. Time to push entire caravan. Push the entire caravan, not a single car. So first car, second car, so we have a 10. So of course we have 10 cars. We have a 10 car caravan. So we have these. 12 seconds. We have 10 cars. So here we have 2 minutes. All right, 2 minutes. And once we have 2 minutes, we have the propagation time, propagation delay. Here, this is a propagation delay. The current distance. So current distance here, and the speed here. So it's an hour. All right, so it's an hour. That says the first car takes an hour, and then it reached the second toll booth. And here we consider the second toll booth gate. Try to close to be, actually we ask the second toll booth close it first. So the first car cannot go in through that one. And so we need to wait the final car, so we just simply have the actual time 2 minutes. So that's why we have 62 minutes. Well, this is the special case. We just want to ask you to have the calculation. Line up at the second toll booth, because we ask you to observe the time to see line up before the second toll booth. It says we don't have the open gate for the second toll booth. So all the cars need to be actually need to reach there and stop there. Well, it says see the entire caravan line up there. So that's why we use a 2-step to have the calculation. Well, this is a special example. Because of the special example, so if I for the real packet transmission or real packet propagation, the first car in fact can go in through the second toll booth. Even for the real case, the caravan can go through the toll booth directly. But why the current example, we do not allow the first car to go in through the second toll booth? Well, it says because of the second toll, maybe one moment later I can re-explain something. I asked previously something wrong. Here, let me reset the phenomenon. Normally, for the car, the second car can pass through the toll booth directly. But here, we ask the caravan should stop there. So that's why we're waiting for the 10th car arrive at the toll booth. So this is actually not the same as the real situation. Well, not the same as the real situation. Let's say second car, first car to the 10th car, well, wet before the second toll booth. So that's why we can have the way to have the calculation. And right now, let us reconsider the mapping. Car is a bit. Caravan, we have the packet. Well, think about the packet transmission. About the packet transmission, do you think the situation the same as the current situation? Previously, I didn't know, maybe not the same, but then we have the correction. It says we have the first car to the 10th car. All right, so this is a caravan. Okay, so it says line up, and so that we can have the special treatment. For the caravan, in fact, we may line up there because the first car perhaps wants to wait for something, wait for the coming of the 10th car. So of course we can stop there. And think about if we have a packet. The first bit to the final bit. If we don't have the final bit, do you think you can have all the details of the packet? No, right? Because of no, for example, we need to know some of you, and so that you know how to have the uplink. And also you need to check any big errors, right? So of course, the current special case for this one line up before the second toll booth. In fact, this one can meet the operation of a packet because you should know all the bits of the packet, and then you know how to have the further processing. So then you have the correction, the current special consideration. In fact, same as the operation of the packet, but not the same as the daily life Caravan. Okay, that's it. So about the current discussion, is it okay? I just want to let you know the special consideration of the Caravan here. In fact, can meet the requirement of a packet, but not the same as the daily life. All right, so this is a way to have the calculation. But later we want to let you know some real phenomena of the Caravan. Well, right now we assume the propagation speed change from the previous value to the current value. All right, if we have this one, 1,000. Previously, we have 100. Well, if we have the current transmission speed, so it says we have this. Well, we have this. Okay, so we have these. And if we have these, and we assume toll booth right now change the time from 12 seconds to 1 minute. All right, so here it says, well, cars arrive to the second toll booth before all cars service at the first toll booth. Well, it says, we want to know the phenomenon. First car leaving, second car leaving, and etc. The other thing about this, we have 6 minutes, and plus its propagation delay, so we have 7 minutes. Well, each car takes 1 minute to be transmitted. So we have 10 minutes required to transmit all the cars. And consider the phenomenon here, 7 minutes for the first car to arrive at the second toll booth. So it's possible. It's possible for some cars still need to be transmitted yourself. So after 7 minutes, the first car arrived at the second toll booth. However, we still have 3 cars still at the first toll booth. Well, this one just want to let you know, of course, for the first toll booth, we know all the information and then allow the bit to go through. But before the second toll booth, in fact, we need to collect all the bits there. Actually, we need to have all the information for the cars there. And then we can have the car to be processed later. All right, so for this one, it says, even for the first one passing through the toll booth, but some of them perhaps still remain at the original toll booth. The first one perhaps reached the second one, actually reached the next one. And for this one, I think even for the packet transmission or propagation, the same. So we may have a situation like this.